So we can move, I think probably this was the hardest exercise, and if I tell you the truth, it's not that useful. Here I was saying to create a dot plot, similar to the one we created up there, right? So, but what we're doing now is taking from the Seurat cluster makers markers SCT, so the top markers of every cluster, we're going to pick the top 2 of every cluster. And out of that, we're going to make a dot plot. So again, I'm not going to make you do this. I think it's harder. If we had time, I'd let you practice and Google stuff, but we don't have much time for Googling now. So basically, I'm asking, let's create a vector of genes that contains all the top 2 genes for every cluster. So if we use the deep-learned approach, so this is the name where we store this information, right? This is the object that contains our table. And we're going to use the pipes. So we give the pipe to the next thing. And I'm mentioning that you can use filter, group by, and top n to obtain the final result we want. So the first thing I'm going to do is filter for, I don't think you maybe necessarily need this, but let's keep only the genes that are significant. It's called p-val adjusted. So p-val adjusted. Right, and we want them to be less or equal than 0.05. Okay, now we remove anything that is not significant in that table, if there's anything like that. Then we want to group by, and you can Google what everything does and all the parameters you can do. We're going to group by cluster. So the next operation we're going to do is going to be at cluster level. Cluster is the name of the column, nothing else. Could be any other column. So we are grouping by cluster. So those operations are going to, sorry, I didn't want to do that. The next thing we're going to do is be affecting every cluster. And I said to take the top n is a way to select the top, whatever you want to select, as a 2 genes. And if we look at the arguments for top, there is one called WT. That's, I don't know what it means, but it's called WT. What we're trying to do here is selecting the top 2 of what? How I need to order the data, right? So, and for that, we're going to use the average log2 expression. Thank you. There is one more thing that I didn't specify in this exercise, which is we only want the gene names. So far what we've been doing is filtering, removing anything that is not significant, operate at the cluster levels, and selecting the top 2 of every cluster based on the average expression. But that is going to return us another table. I don't want the table. I just want the gene names. I don't know if we use that function. I think it was mentioned maybe yesterday. There's one called pool, and you give me, it's called gene. Yeah, gene. So give me the gene name. And this is an extra thing I'm going to add just in case, which is just the unique ones. It could happen that the same gene is a top gene in more than one cluster. I just want it once. I don't need to have the name duplicated. I know this would have taken a little bit of time because I want you to search information yourself and all that. So I thought it would be good if we do it together. Also, it's really cool, right? I think it's more readable if we try to do this using deep-learn and the pipes, so you see what we do in every step. Don't worry, I'll go down, right? The next thing I want you to do is to use the dot plots. I'm probably asking you, always ask, oh, it's here. Okay, well, sorry. Let me take all this. So I don't have to type, oops. Okay, I'm going to have to check a lot of parentheses here. Let me remove all the, did I said save it into a file or not? Oh no, we didn't need to save it, so no saving, out. Now I need to be sure that parentheses are okay. They are not. So any questions on how I selected the genes? I mean, this wasn't an exercise that useful, but I wanted to show off how you can use filtering on the tables to obtain something in a quick way. Dot plot, we already done a dot plot. Oh yes, it's saved to a PDF. We are not going to save it. We're just going to display it. And I think this should work. Hopefully, no. Why not? Oh, it's called top with uppercase. Should I keep it here? I don't know. It seems it's not important. I mean, you can skip this. It's not a big deal. So now, what we have here, and it's quite obvious, right? So we have the clusters on the left side, and we picked the top genes, the top 2 genes of every cluster. So that's why you see that diagonal lighting up in purple, right? Because we already been selecting those top genes for every cluster. Although some of them, like here, right? Cluster 6 and cluster 13, they probably have the top 2 genes are the same ones, or close. They're going to be top. Not the same ones, but they're pretty close. Maybe this information is useful for classification, for cell typing, I'm not sure. Okay, can we do the next exercise? So one thing you can do to make your life easier, maybe, it's you could download. Did we save an Excel? Yes. You could download the Excel file in your computer, open it, and start classifying the clusters or assign clusters to a cell type. You want to try? So we're doing manual cell type classification. And there is no wrong or right answer because I haven't done it. So I don't know. Let's give it a try. I'm giving you some different ways you can do that, right? Search for canonical PBMC markers. That could be a way to do it. Open the Excel, check the top markers of every cluster, see if you identify them. Dr. Amit already identified maybe monocytes, I think it was, monocytes. Yep, cluster markers. One thing to confirm your theory is to, you can visualize them. Once you create a list of markers, you could visualize them. Sorry, what? You have to, there's no Excel reader on the website. So if you do, what is it? I mean, let's do one thing. Why you don't work together in couples or 3 people together? It may be easier, right? So if you group in couples and try to decide. So once you decide cluster 0 are monocytes, come down here in the next cell and say these are monocytes, which I don't know if they are, but let's assume they are, or whatever you think cluster 0 is. And remember, it could be that cluster 6 and 7, both of them are monocytes. So name them as monocytes, both of them, if you think they are. I don't know what they are. So, or call them, even better, call them monocytes 1 and monocytes 2, just in case.
You've spelled monocytes as monocytes.
Oops, sorry. Well, it's anyway, I don't know if they are. This is an example. I'm going to keep it as a cluster 0 for now. I'm renaming the clusters. I'm renaming the cell types. They're wrong.
We have to do it manually.
Maybe. That's exercise. Or, hold on, let's change the tactics. Why we don't group each two people names a cluster differently, tries to figure out what it's each cluster. Why we do cluster 0 over there, 1, 2 over here, 3, 4, 5, 6, I don't know, that corner 7, 8 around there, 9, 10, 11, 12, okay, 15, and forget about 14, 15, and 16. Let's assume that's something else. Use Google too, right? Google may help you. Or or chat, or okay. Yeah, what I mean, you can try. Give it the top tens of a cluster, the top 10 genes, and say what I identify as these that have been top tens in my cluster. Can you tell me what cell type is this? And see what happens. Or give it the whole thing meaning your cluster only, the ones that you think that are the top ones, maybe 50. Be polite, say thank you when you're finished. And remember, let's say you decided to look at cluster. I'm going to look at the top 10 genes of the cluster. Not all of them are going to be informative of what cell type it is. You're running out of time. If you don't find the cluster, the bomb is going to explode. So it's up to you guys.
How did
Okay, you already figured out one? Okay, hold on. Hold on your thought.
Cluster 1 is CD8.
Okay. I don't know the answer, so I don't have the right answer. So we're gonna try our best.
Cluster 1 is CD8.
Okay, hold on. What's gonna happen at the end? It's gonna explode? Oh yeah, it explodes. Okay, cool. Okay, now that you're here close, so what genes in you cluster one?
Cluster 1.
What genes you think are important in cluster one? Just give me
CD8A, B, and B.
CD8A, CD8B,
TLR,
TLR. Look at the screen and let me know if I'm spelling that right. K, like this. Show me to me, probably it's easier, so we don't have to do the spelling contest. Oh, KLR1. Oh, KLRK1. Okay, I got you. Any other one that you think is important?
Yes, the full CCR7.
CCR7. KLR1K. CRR7. It's like that. CRR or CC?
CCR.
CCCR. Okay, yeah, got you. Okay, parentheses. What the heck? Cluster 1 identify these to be key genes, right? Sorry, we cannot read it, but that is, which one? And CCR7. So you can do plots also to test, right? It looks like, yeah, cluster 1 are highly expressed. I don't know. Could it be that there's another cluster? Having all three, there's only cluster 1 that have all three being highly expressed. So maybe they are T cells? CD8? Okay. I don't know if let's keep short names. Maybe it's easier. So should we name what did you cluster 0? What do you think it is? Give me a name. You're convinced they're monocytes? Okay, let's do monocytes. Cluster 1, we said TCD8. I'm going to call it like this for simplification. Cluster 2, what do we have? ChatGPT fail. Okay. ChatGPT. Cluster 3. Another failure. Okay. CT3. Nothing. 5. What is 5? What is cluster 5? Okay, 5. 6. What about 6? Do we have anything? Give me something. Oh, 6 was a harder one. I think it was a tiny one. Yeah, so we're going to go fast. Don't worry about it. We'll figure it out. 7, anything on 7? 8? 9? What do you have? So CD8? Oh, you're giving a gene name? No, I want, what cluster is this? What cell type is this? Sorry. What do you think is a cell type? Okay, CT8. Cluster 9? NK cells. 8 NK cells. Okay. NK9? NK9? Oh, okay. I thought you want me to name them NK9 cells or something. Okay. You're saying these one are the NK cells. Okay. Let's keep it short. 10 B cells. 11. 11 status 11. 12. Okay, it could be. So what?
Cluster 10 is B lymphocytes.
Monocytes, macrophages.
Cluster 10 is B lymphocytes.
8 B lymphocytes.
No, no. 10 is cluster 10 is B lymphocytes.
Okay, B lymph. I know you're not going to be such in a rush. Let's keep it like this and we move on. So we decided that's going to be our clusters. I don't know if we need to merge or not merge. That's something we haven't considered. It looks like we may have multiple B cells, so it could have good idea maybe merging them, maybe. For now, we're going to keep the same structure. So it's pretty explicit what this thing does, right? We are renaming our Seurat object with new clusters IDs. So we're going to take this dictionary that we have here that has the current clusters, and we're going to rename them with our own names. I'm also doing one extra thing, which is in here, I'm counting how many of the cells we have for each cluster. It's a bit flat, but so it looks like we have the macrophages, monocytes, right?
Cluster 2 is also it's monocyte. Cluster 2 is monocyte.
Two. Oh, ChatGPT is also monocytes. It could be next to each other, right? That could be a good merging. Do you want me to merge them so we see how it happens? We're going to keep the same name. So was cluster 2 also macrophages? That's what we're going to say. So exactly the same thing. They're what, sorry? So T cells. Which one? 13 are also T CD8s. That's how we name them, right? Somewhere? Okay. That's it. But we don't have to rename anything else. That's good enough, I think. I like that you get excited about this exercise. That's good. So now we merge a cluster, right? Yeah, we don't have those two clusters that we have here, that it's only one, and I don't remember. We probably merged something down here, right? Those clusters that we merged, the CD8s, they got merged. So this is quite common. Again, our clustering doesn't need to represent cell types directly. It's not one-to-one. It depends on a lot of different things. If you want to subclassify the TCD8s, you could use those two separations that we created. But if not, we could merge them. Questions? Well, here in the next paragraph, I'm just talking about the challenge. You already noticed that we can have really tiny clusters that probably we need to merge with bigger ones.
But there must be inbuilt tools we can do that for us.
That's going to be next, yes. But even the automatic tools, they have problems too. So instead of us making that decision, there are tools available, like single R is one of them. There are a bunch of them. Actually, I think Seurat is pushing for one called Azimuth. So most of these tools depends on some reference database. They need something to be able to make that association, right? And you can do it at two different levels. You could take a cluster and try to classify a cluster as something, or you could classify a single cell as something, and then your clustering, you can throw it away because it's not going to match. If you start classifying cells individually, whatever the algorithm tells you it is, that's going to be the new clustering. The other way is assume that your clustering is good enough and then try to classify your clusters cluster by cluster. So in single R, so we use CellDex to access some database. You have a bunch of them available. I'm not an expert in databases, so I don't know exactly which one is going to be better. I think I choose this one. Instead of going for PBMs specific, I thought this one would give you better. It would be simpler to show than if we go for one that is really specific. But I mean, if you want, you can try, if you comment these and uncomment one of these other ones, you can try different data sets with the next process and see how the difference is. If you notice, remember that I told you this. So in single R, we are not using the SC transform data. And luckily, we've done the normalization that we did initially. We're going to use data say for this.
I have one query.
And another thing we're doing this. Sorry, yes, I need to explain more details. Single R doesn't like the Seurat object. So the format that Seurat object has, it doesn't like it. So we are transforming the Seurat object to one thing that is called single cell experiment format. And we are taking only the RNA assay. So we are forgetting the SCT. So this is like a Seurat object with only this. It's similar. Let's assume that. So now we're going to run single R with this object that we created, which is, imagine is like a Seurat object, and one of these references. I picked that one here, which is more generic. So for the classification, we're going to use the clusters. We're telling single R, use our clusters to classify. It's going to take the whole cluster and try to figure out what is that thing, right? The whole cluster. I think single R can operate at the single cell level, but we are not going to do it. There's, again, Azimuth, you have different Azimuth versions. They operate at single cell level too. Some references, they have different levels of annotation. So they go from level 1, and they tell you, the higher level hierarchies, right? Level 1 is going to be, they're going to take your T cells, all the T cells. It doesn't matter if they're subtypes or not. They have a classify more details. And level 3, they classify even more details. So I'm assuming, I'm not sure what it contains of these, or this specific one and what the levels are, but some of the databases that you may use, they can have different sub-levels. So I've never used these before this workshop. So I don't know many details. I use other tools like Azimuth. I use Azimuth sometimes. But I thought this would be, I guess, easier to understand what we're doing. We're accessing one database, but we can access these other databases that are available. I'm not going to go into details because I don't know them, if I tell you the truth. But one thing, so these are, they're not going to give you the truth, right? They're going to do some statistical analysis. They're going to give you some sort of a score and tell you the most probable cell type is this. They probably have other type of, so let's say, some of them they're going to tell you, I'm 60% sure this is a monocyte. But what about the 40% left, right? I'm also thinking maybe it's a B cell or whatever. So sometimes you may get a single label out of a program like this, But you need to think that there's a confidence of interval inside of that estimation. It's not the truth. They're not giving you a single answer a lot of times. There could be more than one answer. I'm explaining that idea a little bit, yeah?
So for T cell, it is not specifying that it is CD8 or CD4.
No, that depends on two different things. How good is your reference? So if you're working with a reference of primary cells in your body, they're not going to be really specific. If you go to a reference that is specific for PBMCs, maybe you get more details. So your choice of reference is going to define how good is going to be your final goal too. But again, these softwares, they're not, first, there are two things. They may be incorrect, and they're always incorrect at some point. They're not always 100% right. And second, they always have they give you some confident value about how confident they are that every cluster is whatever they think it is. They are. So this is our results. It's been quite generic, right? We give them monocytes. I think we were right on that one, right? We said monocytes, macrophages, so this was right. Did we set B cells on top? Yes? Okay, that's good. Definitely we said these were T cells. I don't know what we said about these ones, but it classifies everything as T cells. Did we set it with NK? So we fail in that. We may fail on that. We're assuming that Singular is doing a good job, but we don't know. Yep? So if you change the database of reference, you may get different results. So if you try the specific one, I don't know, let's see what happens. Oh, there's the azimuth. I didn't know I added. Okay, this was the reference for PBMCs. It's a bit better in the classification. I guess we want more detail. This is giving us a little bit more detail. NK cells, so even if we change the reference, they insist these are NK cells. CD8 positives, that's what we said, right? This group was. So we were right about that one. Still monocytes, dendritic cells. I don't know if it makes sense. It makes sense?
Yes.
Yeah, please.
This is by R from date 2 actually. But you have done previously more to identify the cluster. We didn't get actually. So can you explain it again?
Which part?
From
The,
Excel.
How to identify the cluster?
From Excel, right?
from here?
No, actually some people didn't get that you have to download that Excel and look at the genes and try to guess.
Yes, that was the goal. Download the Excel and from that table try to guess what it was. Yes, that was the idea. From the cluster-specific markers, I would call them, try to figure out what the... Yeah.
Actually on the Mac it is not opening.
It's not opening?
No, I have downloaded it but it's not opening. Numbers पे खुल नहीं रहा है वो लोग को।
अच्छा वर्ड डॉक्यूमेंट होगा मैंने में माइक्रोसॉफ्ट वर्ड है ना
मेरे Mac पे वाला अपलोड हो जा रहा है पर वो ओपन नहीं हो रहा है।
हाँ वो माइक्रोसॉफ्ट वर्ड नहीं होगा माइक्रोसॉफ्ट
नहीं मेरे पे नंबर्स है ना तो उसको
हाँ
नंबर
तो
उसको एक्सेल को नंबर्स की मेरा कुछ मिसमैच करके बोल ही नहीं रहा है।
So we didn't get, NK cells. We placed them here, the NK cells. We were wrong. In theory, we are wrong about the NK cells. So another tool, that's the one I was mentioning, Azimuth. If we run this, if you want, you don't have to run it. This is just the last exercise. We give indirectly the Seurat object, and let's see what we get out of it. So this is one of those tools that you could, there are different levels of classification. So from generic, middle, I think there are 3 levels to detail. I think this is going to be way too much. I don't know how it's going to look like, but I'm assuming
It looks quite crowded actually.
it looks really crowded. Yeah.
But it has classified even the B cells into different subsets.
Okay.
Naive, memory.
So in this case, is ignoring our clustering. It's throwing away the clustering and goes cell by cell and trying to classify cell into something. Oh, it's accurate? You are the biologist? I don't know if you're a biologist. Maybe you are the biologist, you need to tell me that. So it is using, let's say, a very big data.
Sometimes the labels are hiding the cluster itself.
I know. Then we need to play with the labels and see. I mean, we can change these and go a level up maybe, so we get less classification. Or then you can manipulate the table and say, show me only this group, so I can see where they are instead of showing me everything. Did it match our previous expectations? Like NK cells are still being NK cells? B match? Okay. Oh, it finished, right? So CD8, it matched. So this one also CD4, Bs. Yeah, NK cells are here, right? They're still here. Yeah. So here gives a mixed. Definitely monocytes and something else. Oh, a different type of monocyte. So yeah. Yep. Questions? Generally, we do both. We do it the other way around. So first we do something like this, and then let's say the investigator confirms whatever they think is correct. We generally we don't need everything on the analysis, right? People wants to focus on a few cell types and then ignore the rest. So
Some cells are very few in number, like plasma cell in the periphery will be very few.
yeah, I don't know what it is here. I don't know. Is expected to have only a few plasma cells on PBMCs?
Very, very few.
Okay, so it's,
PDCs also will be very few.
I don't know what's a PDC, I have no clue.
It's a plasma cytoid dendritic cell.
Okay.
And
So
also you got a megakaryocyte also. Megakaryocyte is in the marrow.
it's somewhere behind this label, right?
So it is a megakaryocyte.
Okay.
So normally you should not see a megakaryocyte in the peripheral blood.
So let's do. So it's usually repel. Sorry, how is the spell? G repel. It's not called like this. How we use it? Okay, it doesn't matter. And as always, remember at the end of your notebook, you can record your session, save it in a file. So any questions?
No, but if you want to see that megakaryocyte, it's a separate cluster, is it? Like which cluster number is it?
Well, azimuth, again, ignores your clustering.
And it doesn't tell you where the cluster was.
No, it's so when you run Azimuth, you are classifying cells. At that point, you're clustering. Whatever you've done previously is gone.
So the cluster information is not there now.
No, it's not there, and it's never been there for Azimuth. So when you provide Seurat to Azimuth, your classification of clusters is not taken into account for anything. It goes cell by cell. So in the previous exercise, what we did is single R takes a whole cluster and tries to tell you what it is. In this case, it takes only one cell, cell by cell.
I have one question. This is one sample data, right?
Yes.
How the log to fold change are coming? What we are comparing? What with what? The genes they are giving the log to fold change.
Yes. So the log24 change we got earlier, it was comparing every cluster with the rest.
Okay.
So cluster 0 with all the other cluster.
The rest of
Yes. So that's how we identify what I call cluster-specific genes, right? They're not 100% specific because sometimes you see them in different clusters, but that's the idea.
But how is Azimuth so fast in the sense that Suret is going to do it cluster by cluster, but
Yeah.
this is going to do it by cell,
I know. I don't know.
so
I don't know the details.
return outputs
Yep.
quite fast.
Yeah. This is it connects to the internet. By the way, you cannot do this without internet connection.
So if I'm going to manually evaluate, right, like I just want to confirm like how I manually evaluated the
Yeah.
cluster. Basically I should sort them by like the log, see whatever, and like take whatever like is the highest popular like genes, and then compare them to whatever canonical
Yep. Yep. Yeah. And if you probably Google PBMC canonical markers, you're probably going to get a table.
yeah, I got a whole list.
Yeah.
So that's how.
But sometimes there are clusters that are really hard to classify because the clustering is going to maybe create a small cluster and there's not enough genes to classify. There's always complications. It's not that easy. So for a sample like this, there's not much less left to do, right? We classify the genes. I don't know. We could do a comparison between T cells if we want to.
Will we do the myeloma exercise also?
We could. It's depending on what we want to do next.
Some parts we can do the myeloma exercise.
We can try, yeah. So before I move on, any questions about this notebook? One thing I can do is try to go fast through the next one in case. What do you think, Bonnie?
We'll do the functional and then you come back after the talk and then they want.
Yes? Okay. So we're going to take a rest now from single cell and he's going to do functional analysis. Oh, no, sorry. As always, Bonnie is not prepared on time.
He was doing it in the morning.
Yeah, exactly. He had months to prepare for this.
This workshop is actually pretty light, okay, in its content. So if you ever get a chance to attend some of the Cold Spring Harbor's workshops, usually they are 3 weeks long workshop, okay, and So I did one of them for functional genomics statistics. Yeah, so they have this one, the statistics for functional genomics. So it's a bioinformatics basically, 3 weeks. So 3 weeks, every day it will start at 9 o'clock, then go all the way till 5 o'clock, then you will get 2 hours break, then 7 to night 12. And this you are doing like 3 week stretch, like not Saturday, Sunday also there is no break. Only one Sunday they will take you out for a like a team building kind of a stuff, which is too fun. I actually took this workshop and then I came and slept for like 3 days straight. Like and the worst part is this 7 o'clock on, so they will 5 o'clock they will have a like break, 6 o'clock they will serve dinner, and then 7 o'clock onwards it's hands on, like you will whatever they taught you will be doing those exercises, and the course people will be there helping you to like, so basically whatever you learn in the morning you will have exercises to do, and this, and there will be alcohol actually. So people start drinking from like 7 and everybody is like
Till morning 7.
no, so till 12. So 12 is like normal, and then after that there is a bar in Cold Spring Harbor. So where Watson used to come and we used to meet Watson there. That people will actually stay there till like 2 o'clock, 3 o'clock, depends upon how long they want to be. There was a faculty, he was a crystallographer in University of Florida, and he at that time I was like in 35 or so. He was in 50s, and he was doing straight 5 o'clock every day in day out, like for 21 days straight, and just 4 hours sleep. During that time he also did his analysis also. He brought a data with him. Basically he learned everything and analysis, and he analyzed his own data, everything ready for paper for him. Just and same thing, like they have 5-day conferences. Again, that every single day it will start at 9 and end at 12:30 in the night. Main keynote speakers are actually scheduled for like at 10:30 in the night. The last talk will be the keynote, and they will be like some very big shot, and everybody wants to listen. That means you cannot go anywhere. And again, after 5 days of conference, you think like, okay, I know I don't want to live anymore. Just let me die. Allow me to die. So, yeah. Cold Spring Harbor will give you travel grants. Apply for that. Those workshops are amazing. I mean, if you get into one of those workshops, I will show you their web page actually. They have a whole series of there is a one on genome also is there, but no, they are actually year round. So and it's actually permanent one. So yeah, you should attend one of those workshops. It depends upon how you want to use it. I mean, end of the day, it's fun. I mean, once you come back from there, you will be completely changed person. Like, this is Cold Spring Harbor. I will show you the website. So the good thing about Cold Spring Harbor, so it's a mecca of molecular biology. All initial molecular biology discoveries were done in Cold Spring Harbor, like jumping gene. Barbara McClintock was there. Hershey and Chase experiment that was done in Cold Spring. So every single then microRNA discovery by Gregory Hannan, all those. So every single big molecular biology discoveries were done from Cold Spring Harbor. And when you go there, if you are a molecular biologist, you will just feel goosebumps, like, oh my God, I studied these guys. And there's a house where, it's in Long Island. There's a house which is nobody's using. It used to be Barbara McClintock's house. So it's a quarters. So she first proposed that genes can jump. So transposon, she said, and nobody actually believed her. And she almost like secluded herself for a long time before it was rediscovered. And so that house is still there. And it's beautiful. It's a coastline, and you can have fun. I mean, that place is fun. I actually took my son and wife recently when we do Cold Spring Harbor, Long Island, and so I was actually told, okay, let's go there and show this place to them. It's a beautiful place also to just visit also. but it's too nerdy to take wife and son to a research lab. I know that.
So if you want to induct your children into research,
No, he is actually. No, no, no.